My name is Paul Weathersby. I'm the Director of Technology Programs at Harrison College. You can find out more about our college and programs by visiting us online at www.harrison.edu. Today's topic will cover variable length subnet mask. I'm going to describe a method I refer to as the 128 method because the only number you need to remember is 128 in order to build the blocks and charts that can be used to find any answer to a subnetting question. We need to go back a little bit and understand binary at its most basic level. Binary describes a numbering scheme that has only two possible values for each digit, a 1 or 0. You can also think of the bit as only having two possible states, either off or on. Now, they may look a little strange when written out directly because their value increases by a power of 2 rather than like base 10 value, which is what we're probably used to seeing like 1, 10, 100, 1000, etc. So in this example, to convert a decimal value of 21 into its binary form, a computer would see that byte represented by turning on the first, third, and fifth bits. And in doing so, you could take the sum of 1, 4, and 16 to equal 21. So now that you have your binary and decimal references, we want to see how we can use the 128 block to convert an address into binary form. In IP version 4, there are 32 bits that represent the IP address. So if you have an address like 134.68.70.10, let's take a look to see how that's converted into binary form. If I look at the first number, 134, in the first octet, the number 134 is converted to binary by turning on the second, third, and eighth bit. In the second octet, you have the number 68. It gets converted into binary by turning on the third and seventh bit. The number 70 gets converted by turning on the second, third, and seventh bit. And the number 10 gets converted by turning on the second and fourth bit. So you should be set on your binary reference using the blocks. But you might be asking yourself, how do I just use one block to help me with subnetting? What you have to remember is what class you're in. Whatever IP address you're working on, you first need to identify the class. There are 5 classful boundaries that we will discuss. Primarily, we'll focus on the first 3, Class A, B, and C. The Class A boundary are any addresses within the first octet that are between 1 and 127. They have a subnet mask of 255.0.0.0. That is the default subnet mask. Class B classful boundaries have addresses in the first octet of 128 to 191 with a subnet mask of 255.255.0.0. Again, the default subnet mask. Class C would be 192 through 223 with a default subnet mask of 255.255.255.0. Class D addresses have an address between 224 and 239 within the first octet. Those are for multicast. And Class E, which is experimental, have addresses between 240 and 255. We can use the 128 block to help us remember what the class ranges are. If we take a look at our block and we add across from left to right, we would have 128 added to 64 equals 192. 192 plus 32 equals 224. 224 plus 16 equals 240. 240 plus 8 equals 248. 248 plus 4 equals 252. 252 plus 2 equals 254. And 254 plus 1 equals 255. One thing that we need to mention when we're talking about addresses, the different classes of addresses, is public versus private. There are private addresses within the classes that do not route. You need to be aware of what these are. In Class A, it's 10.x.x.x through 10.255.255.255. In Class B, the private address scheme is 172.16.x.x through 172.31.255.255. And in Class C, the private address scheme is 192.168.x.x through 192.168.255.255.